In real life, we come across situations that require precision, that is, in painting patterns on tiles and in construction of tangents to a given circle that passes through a given point. How do you think such situations are solved? The concept of similarity of triangles comes to our rescue, which states that the ratio of any two corresponding sides in two equiangular triangles is always the same. This is basic proportionality theorem or the Thales theorem. Let us do an activity to understand proportionality. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Draw any angle XAY and mark points P, Q, D, R and B such that AP is equal to PQ, which is equal to QD, that is equal to DR, that's equal to RB, which is equal to 1 centimeter. Through point B, draw any line intersecting arm AY at point C. Also through D, draw a line parallel to BC to intersect AY at E. We have AD is equal to AP plus PQ plus QD, which is equal to 3 units. DB is equal to DR plus RB, which is equal to 2 units. Therefore, AD by DB is equal to 3 by 2. Now, measure AE and EC and find AE by EC. To find that, AE by EC is also equal to 3 by 2. Therefore, AD by DB is equal to AE by EC, which is equal to 3 by 2. Here, we observe that in triangle ABC, if DE is parallel to BC, then AD by DB is equal to AE by EC. So, when parallel lines are drawn to one side of a triangle, these lines divide the other sides in equal proportion. This result is proved as basic proportionality theorem or Thales theorem. Statement of basic proportionality theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. ABC is the given triangle and L is the line that is drawn parallel to BC, which intersects side AB in D and AC in E. It is required to prove that AD by DB is equal to AE by EC. Let us do some construction to prove this. Join BE and CD and then draw DM perpendicular to AC and EN perpendicular to AB. We know area of triangle is equal to half into base into height. Area of triangle ADE is equal to half into AD into EN. This can also be written as equal to half AE into DM. Also, the area of triangle BDE is equal to half into DB into EN, and area of triangle DEC is equal to half into EC into DM. Taking the ratio of the respective areas, we get area of triangle ADE is equal to half into AD into EN, which is equal to AD. Area of triangle BDE is equal to half into DB into EN, that is equal to DB. Area of triangle ADE is equal to half into AE into DM, which is equal to AE. Area of triangle DEC is half into EC into DM into EC. Here, we observe that triangle BDE and triangle DEC are on the same base DE and between same parallels BC and DE. So, area of triangle BDE is equal to area of triangle DEC. Therefore, from 1, 2 and 3, we have AD by DB is equal to AE by EC. Thus, the line L, which is parallel to segment BC, divides line segments AB and AC in the same ratio. If in a triangle ABC, a line DE is parallel to BC, intersects AB in D and AC in E, then it can be proved that 1. AB by AD is equal to AC by AE. 2. AB by DB is equal to AC by EC. 3. AD by DB is equal to AE by EC. 4. DB by AD is equal to EC by AE. 5. AD by AB is equal to AE by AC. 6. AB by DB is equal to AC by EC. 7. DB by AB is equal to EC by AC. This is the statement that follows with little or no proof required from an already proven statement. Given that DE is parallel to BC, find AD in Figure 1. Here, according to basic proportionality theorem, a line drawn parallel to any one of the sides of a triangle divides the other two sides proportionally. AD by DB is equal to AE by EC. Substituting the known values and solving for AD, we get AD is equal to 2.4 centimeters. B. Given that DE is parallel to BC, find EC in Figure 2. Applying BPT theorem, we have AD by DB is equal to AE by EC. Substituting the known values and simplifying, we get EC is equal to 2 centimeters. ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at point O. Show that AO by BO is equal to CO by DO with the help of basic proportionality theorem. In triangle ADC, OE is parallel to DC. Therefore, by basic proportionality theorem, we have the following relation. AE by ED is equal to AO by OC. Consider this as equation 1. Similarly, in triangle ABD, OE is parallel to AB. Therefore, by basic proportionality theorem, we have AE by ED is equal to BO by OD. Consider this as equation 2. From 1 and 2, we have AO by OC is equal to BO by OD. Rearranging the terms, we get AO by BO is equal to CO by DO. This is the relation that had to be proved. Is the converse of the theorem also true? Let us perform the following activity to examine this. Draw any angle PAQ. On ray AP, mark points B, C and D such that AB is equal to BC, which is equal to CD. Similarly, on ray AQ, mark points E, F and G such that AE is equal to EF, that is equal to FG. Then join CF and DG. As these lines divide in a certain ratio, we have AC by CD is equal to AF by FG. We observe that DG is parallel to CF. Thus, if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. This is converse of basic proportionality theorem. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Here, ABC is a triangle and DE is a line that intersects AB in D and AC in E such that AD by DB is equal to AE by EC. It is required to prove that DE is parallel to BC. Let us assume that DE is not parallel to BC, and then there must be another line parallel to BC. Let DF be parallel to BC. Then, from basic proportionality theorem, we get AD by DB is equal to AF by FC. Let us consider this as equation 1. But it is given that AD by DB is equal to AE by EC. Consider this as equation 2. From 1 and 2, we get AE by EC is equal to AF by FC. Adding 1 on both sides and simplifying, we get AC by EC is equal to AC by FC. This implies EC is equal to FC, which means E and F must coincide. So, DE is parallel to BC, that is, the line L is parallel to BC. Verify that segments DE and BC are parallel, that is, DE is parallel to BC. Taking the ratio of the sides, we get AD by DB is equal to 30 by 20, which is equal to 3 by 2. AE by EC is equal to 24 by 16, which is equal to 3 by 2. We observe that AD by DB is equal to AE by EC by converse of BPT. Therefore, DE is parallel to BC. In triangle OPQ, DE is parallel to OQ. Applying basic proportionality theorem, we get PE by EQ is equal to PD by DO. Consider this as equation 1. Similarly, in triangle OPR, DF is parallel to OR. So, by basic proportionality theorem, we get PD by DO is equal to PF by FR. Consider this as equation 2. From 1 and 2, we get PE by EQ This implies EF is parallel to QR. Now, let us know more about Thales. Thales is considered the first philosopher and scientist who was born in Miletus in Greece and lived in the 6th century BC. Thales was interested in almost everything. He investigated almost all areas of knowledge: philosophy, history, science, mathematics, engineering, geography, and politics. 5 Euclidean theorems have been explicitly attributed to Thales. Thales wanted to know the height of the Great Pyramid. He decided to measure it himself. The method he used is still so popular. He chose a time of the day when the height of the shadow of the pyramid was equal to its actual height, and then measured the length of the shadow, which gave him the measurement of the height of the pyramid. For this, he had to understand proportion and possibly the rules governing similar triangles, one of the staples of trigonometry and geometry.